So as we know, in yesterday's class, we discussed three different kind of acceleration. One is centripetal acceleration. Second one is tangential acceleration, and third one is net acceleration. So if you take the centripetal acceleration, what is the formula? Actually, everybody, centripetal acceleration is equals to v square by r, or we can say r omega square. Same way, tangential acceleration means, we all know that tangential acceleration means what? Tangential acceleration means d mod v divided by dt. So here v means not speed, it is not velocity. It is what is that?
Speed.
That is what you have to remember. So net acceleration, what is the formula? It is the
Root over AC square
mod of dv by dt, or which we can say that root over centripetal acceleration, square of centripetal acceleration plus square of tangential acceleration. So we have solved some numericals also related to that. Am I correct, everybody? Yes. Yeah. So now let us comes to here. Today's class we are going to discuss the next type of acceleration. So that is what the fourth type of acceleration, which we used to called as, what is that, everybody?
Angular acceleration.
Angular acceleration. So if you have taken angular acceleration, so let us see that. So what is the symbol of angular acceleration? Alpha. Understand? Alpha is equals to delta omega divided by delta t. So what do you mean by delta omega? What do you mean by omega? Everybody.
Angular velocity.
It is called as angular velocity. That is what. Now, so this is the formula for angular acceleration. So this is very simple. So if you compare the linear and angular, so we all knows that we'll get it everything clearly. So linear, what is the displacement, everybody? Yes. And what is the angular displacement, everybody? You should respond. Theta. And speed or velocity in linear displacement is v. And what is the angular speed or angular velocity? Omega. Yes or no? And if you want to find v, if you want to find the speed from the distance or displacement, what is the formula? Velocity is equals to ds by d theta. Same way, angular velocity is equals to, what is the formula? D theta by d. Now, next, rate of change of velocity. Rate of change of velocity, what we used to call? Acceleration. So dv by dt. Same way here, if you want to find angular acceleration, so what will come? dw divided by
d omega by dt.
Understanding? So that is d omega divided by dt. So that is what is the difference between linear and as well as angular motion and linear motion. Everybody clear with that? So what is the alpha formula? Everybody, angular acceleration alpha is equals to delta omega divided by everybody delta t. Clear? Yes. So now let us take, for example, if I take angular acceleration, average angular acceleration, then what is the formula will come, everybody? That is what? Delta omega divided by delta t. For example, very short period of time, almost time interval is 0. So means in the sense of what will come? Almost time period is 0. Almost time is 0. So that we used to call something. What we used to call, everybody? Yes, please. Yes. Very short period of time. You have taken short for short period of time. Then what will come? All of you? Instantaneous angular acceleration, which is equals to what will come instead of the delta, we will get what? dw by dt. So that is what? Instantaneous acceleration, average angular acceleration, and instantaneous angular acceleration. Everybody clear? Yes, please.
Yes.
All of you?
Yes, sir.
Yeah, that is what you have to remember. So this is what, write it, angular acceleration formula. So now, so let us take q is equals to, sorry, next question. So omega is equals to t square plus 1. So let us take now, find angular acceleration in 0 to 2 seconds. They are asking 0 to 2 seconds. Means what we have to find? Instantaneous angular acceleration or average acceleration? Everybody. Average angular acceleration. Understanding? And at 2 seconds. So at 2 seconds, specifically they are mentioning the time. Then what do we have to do it, guys? We have to find the
Alpha instant.
response. Instantaneous
Instantaneous angular acceleration.
instantaneous angular acceleration. Am I right or wrong? Everybody clear? Yes, similar sums we have solved. So then angular acceleration, average angular acceleration. What is the formula? Angular acceleration formula is equals to
EW.
delta omega divided by delta t. So we are having from where to where average 0 to 2 means
0
let me
to 2.
consider average acceleration here is like omega angular velocity here is omega 2 and here angular velocity is omega 1. So
Omega.
that what will happen? Average angular acceleration means
Omega
change
2
angular
minus
velocity.
omega 1.
What it is? Yes or no, guys? Angular average means yes, please. So what will happen? Omega 2 minus omega
Minus
0
omega
divided
0.
by what is the time period? 0 to 2. What is that totally? 2 minus 0, which is equal to how much? 2. Okay. So what is the given function? Omega is equals to verify it. Omega is equals to what? Yes, please. T square plus
square.
1. So then T is equals to 2. Let me substitute. What will happen? 2 square plus 1, which is equals to how much? Omega 2 is equals to 5. Same way, T is equals to 0. Then omega 0 is equals to how much it will come? 0 plus 1, which is equals to how much? 1. Okay. So that is what? 5 minus 1 divided by 2, which is equals to how much will come, guys? 4 by 2.
2.
Is equals to how many radians per second? All of you.
2
Radian per second, radian per second square. Aksha, average acceleration is. So radians per second square. Radians per second square. Yeah. Everybody understood? Yes. That is what. Next, at 2 seconds they are asking. So at 2 seconds means what is that, guys? Average angular acceleration, instantaneous acceleration.
Angular
equals to
D omega.
dw by dt. So d omega, w or omega, whatever it is. So what is the omega function, everybody? T square plus 1 divided by dt. So apply the differentiation and tell me what is differentiation of t square, everybody? Differentiation
2t.
square. So I can write this one as differentiation of t square divided by dt plus d of 1 divided by dt. So tell me what will happen. Differentiation of 2 square is equals to 2t.
2t plus 2.
Value 0. What is the answer?
2t.
dw by d omega by dt is equals to 2t. Now t is equals to how much? At 2 seconds they are asking.
2.
At 2 seconds. So that what is the answer? 2 into
4.
2, which is equals to how much, guys? 4 radians per second square. So that is what you have to find it. If they will ask you, always in between the time intervals, keep in mind, in between the time intervals, it is indicating average angular acceleration, and particularly at a particular time period, that is indicating what is that? Instantaneous angular acceleration. Clear, everybody? Understood or not? All of you?
Yes, sir.
Yeah, that is what. So please solve it. One and Samya understood? Monish, you have to watch yesterday's videos. Princy, clear? Rishi? That is what. Yeah, please solve it. Call to Aswita. Clear, everybody? Anything doubt in this? You can ask. Complete the question. Mr. Rishi completed? We'll start out. Next. So those understood or? So from this, let us consider after acceleration, we'll consider linear and angular acceleration. What is the difference from the beginning? So let me take the linear, and if I take the angular, so all of you observe very carefully, linear displacement will represent with what, guys? Linear displacement will represent with the yes. And angular displacement will represent with what?
Theta.
All of you, theta. So what is the
Theta.
relation between S and theta, everyone? S is equals to what? We all studied that. R
theta.
theta. Same way, differentiation of this one, ds by d theta will give you something. What will gives you?
V.
All of you.
V.
V. Same way, differentiation of theta will give you what? will give you
Omega.
omega. So same way, differentiation of velocity will gives you what? Everybody? Acceleration.
Acceleration.
Same way, differentiation of omega will gives you what? Everybody?
Angular
Angular
acceleration.
acceleration.
Angular
So observe very carefully here. If s and theta, s is equals to r theta, same way v is equals to, we have got some formula. V is equals to what? Everybody verify it and tell me. V is equals to r omega. Do you remember everybody? V is equals to r omega. We got it or not? R omega or r omega square? Verify it. Omega square. That is angular acceleration. Sorry, centripetal
No, sir.
acceleration. So what is the formula? V is equals to, I have taught you already. R omega.
R.
Verify it. Yes or no, Rudra?
Yes, sir.
Yeah, same way then. So dv by dt is equals to acceleration means, then from that I can say acceleration is equals to what? Everybody? R what? R into angular acceleration. Clear? So this is very, very important one. So we can say A is equals to linear acceleration is equals to radius into what will come? Everybody? Radius into?
Angular.
Yes, please. Angular? Radius into? Angular acceleration. Okay. So here, whenever I say radius, we all knows that, all of you keep it in mind, whenever I will say this linear acceleration, means in the sense of keep it in mind, that is a tangential acceleration. What acceleration it is? It is the, what acceleration it is? It is the tangential acceleration, because linear acceleration means if you have taken that, this is only we used to call as linear acceleration. Am I right or wrong, everybody? Yes, please. At every point, wherever it is present, at every point, we suppose here velocity, velocity, velocity. Acceleration means along the tangent only. That is only we used to call as linear acceleration. Am I right or wrong, everybody? Yes, please respond, guys. That is what. So whenever I will say A is equals to R into alpha, alpha means angular acceleration. Keep it in mind that it is what acceleration? Linear acceleration. Actually, it is a what? Everybody? Tangential acceleration. Okay. So now always remember R is what? Always remains what? R is remains constant, because R means what it is actually? R means what it is? Radius. That is what you have to remember it. Is it okay, everybody? Clear? Understand? Yes. So what is the relationship between S and theta? S and theta relation is S is equals to R times of theta, and V and omega, what is the relation? V is equals to R times of omega, and A and alpha relation, A is equals to R times of angular acceleration. So that is the thing. So whenever I say this linear acceleration, means it is actually a tangential acceleration. So AT is equals to, so what I can say, tangential acceleration is equals to R times of angular, R times of angular acceleration. So that is what you have to remember it. So please make a box, tabular column, and finish it fast. Do it quick. Is it completed, Rudresha?
Yes, sir.
Now, I'll ask you the question. If the speed of the body, speed means mod v, that is what mod of velocity, that is what magnitude of velocity, will say speed. If the speed of the body is constant in a circular motion or whatever it is, now you tell me, what are the accelerations are zero? Centripetal acceleration, tangential acceleration, and net acceleration, and now what acceleration, everybody? Angular angular acceleration. So now, so I already taught you, whenever the body is said to be in circular motion, then immediately one is always present. What is that, everybody?
Centripetal acceleration.
Centripetal acceleration. So centripetal acceleration will never be equals to 0. So whenever the body is said to be in circular motion, always some acceleration is present. That acceleration will never be, all of you, 0. Okay. Next, what about the tangential acceleration? We all knows that formula is d mod v divided by dt. So which is equals to v is constant, means in the sense of what? No
Zero.
change in v, which is equals to what?
Zero.
0. Do you all understand, Ra? All of you?
Yes, sir.
Yes, please respond. That is what. Now, net acceleration. So net acceleration will, tangential acceleration becomes 0. But what about the net acceleration? Net acceleration will never become. Yes, please. 0.
Never
Why?
become
What is the net
0.
acceleration formula? Tangential
Because
square root over centripetal acceleration, square of centripetal acceleration plus square of
0.
tangential acceleration. So maybe the tangential acceleration becomes 0, but still centripetal acceleration is there. So that is why it will never be equals to what, everybody?
0.
Now, if speed of a body is constant, then what about the angular acceleration? That is what is my question, everybody. Yes, please. Just now I have taught the relation. Tangential acceleration is equals to r times of angular acceleration. Now, from that, let us find angular acceleration is equals to tangential acceleration divided by radius. Now, just now already we got it. Tangential, what is the
0.
acceleration? Everybody. Yes, please. Tangential
0.
acceleration is 0. So that 0 by radius, which is equals to what, everyone?
0.
0. So
Zero.
very important thing. So all of you remember, whenever the speed of a body remains constant in a circular motion, only two accelerations are existed and two accelerations are 0. What is the two accelerations are existed? One is centripetal acceleration and
Centripetal.
another one is what?
Net.
Net acceleration. And what is the remaining two accelerations are 0? Everyone? Tangential acceleration and angular acceleration. Very important. Okay, so please make it. Okay, sir, how, sir? Let us discuss now. So we all knows that what is a omega formula, Pradosh? Omega formula, r is omega is equals to what is the formula? All of you.
d theta by d.
V divided by r. Okay, delta v by the r we can take. So do you remember omega is equals to v by r formula? Yes or no? So now they are saying that v is remains constant. V is remains constant, and all we all knows that already we knows that r is also what, everybody?
Constant.
Constant. Means constant by constant means omega also will come what? Omega also
Constant.
will come what? Everybody?
Constant.
Omega also will
Constant.
come constant. Now, what is the angular acceleration formula? Angular acceleration dw divided d omega divided by dt. So if the omega is constant means, then what is the angular acceleration? Everybody?
0.
0. That is what you have to remember. Is it okay, everyone? Yes, please.
Yes, sir.
Yeah. So please remember that. Any problem for anybody? Yes. Clear?
Yes, sir.
Understand? Ra?
Yes, sir.
So this is the most important one. Okay. So please remember that. So as it is, magnitude is not changing, definitely it will be going to 0. So if the speed of the bodies remains constant, two accelerations are 0 and only two accelerations are existed. Is it okay, everyone? Clear? Yes. All of you?
Yes.
That is what. Okay. Next, you can see, all of you, we can take it now. Let me take one more question and we'll make it. So all of you observe very carefully. If, for example, mod of v is equals to constant. Now, if you take it here in a circular motion, what motion it is? In a circular motion. So we have been made that first one, alpha, angular acceleration is equals to what? Angular acceleration is equals to also a constant. So which is equals to what? Angular acceleration is equals to 0.
0.
And I'm asking you next, tangential acceleration is equals to 0 and centripetal acceleration, which is equals to v square by r, which is equals to 0. So now you tell me, so what is why the centripetal acceleration is not 0 always? Yes, please. Because whenever the body is said to be in circular motion, always what is existed? Everybody, centripetal
Centripetal.
acceleration. Understanding?
Acceleration.
So that is what you have to remember it. So always you remember whenever the v is constant, always angular acceleration is 0 and tangential acceleration is 0. But who is not 0? Everybody?
Centripetal.
Centripetal acceleration. So it will never be equals to 0. That is what? Because you can see, if you notice it in a circular motion, either the speed is constant or direction is of course direction is continuously changing. So at every point the centripetal acceleration is acting towards the what? Everybody, it is acting towards to the center
Center.
or towards the center, or we can say along the what?
Along the
Along
radius.
the radius. Understanding? So that is what. So if the body is said to be in circular motion, always definitely one acceleration is existed. So one acceleration is always present for the body. So that is what we used to call as what? Everybody? Yes.
Centripetal.
Centripetal acceleration. So always keep it in mind. If v is constant, then we all knows that r is already remains, we all knows that constant. Then omega also will become what? Everybody, just now we have solved. Omega is also constant. Then what will happen? Angular acceleration is equals to, everybody, 0. Okay. So angular acceleration and linear acceleration relation. So what is the relation? R into alpha. Okay. So whenever I say linear acceleration, it is actually what acceleration, guys? Tangential. So that is what you have to remember. So this is what about the fourth type of acceleration. I hope you all understand. Anyone having any doubt, you can ask me. Clear, guys? Everybody? So when v is constant, automatically two accelerations will become 0. What is that accelerations? Tangential acceleration and as well as angular acceleration. So that is what you have to remember. Is it okay, guys? Everybody?
Yes, sir.
Yes. So this is what about the types of accelerations. Now, till now, if you notice it, we are always discussing only what is the direction of motion, how the body is moving, what is the speed of the body, or what is the velocity of the body. So whenever we are discussing about the like these things, like what is the position of the body, how the body is moving, how the body is rotating and all, this thing we used to call as a separate branch of this one. So we used to call as kinematics. That is why we can say we have to keep the heading. Have remembered at the beginning of the chapter, we have kept kinematics, yes or no? So which will deals about the motion of a body, like how the body is moving, in what path it is moving, this X, Y, Z and all. So in this kinematics, we are not at all going to discuss anything related to terms like force, understanding, or magnitude of force and all. So now, if the body is in continuously, if you take the circular motion, always body is said to be in what, guys? Every point direction is keep on changing, even though the magnitude of velocity is same, but velocity is not constant. Why velocity is not constant? Because always something is changing. What is changing? Direction is changing. So as it is direction is changing, so definitely we know that direction of change we used to call something. Change in direction, what is to called as velocity. So velocity is also changing. So velocity changing means body is said to be in what motion? Everybody? Accelerating. Understanding? So body is said to be in accelerated motion. Then who is making the body to accelerate? Definitely somebody is exerting the force. That is only we used to call how much force is exerting, how it is exerting. That is all we are going to discuss. So that is only we used to call as centripetal force. All of you write it. What is the next concept, all of you? Centripetal force. Okay. So whenever we are talking about the force, then we used to say it is not the kinematics, it is we used to call as dynamics. Okay. So dynamics of circular motion. That is what we are going to discuss now. So till now we discussed what, guys? Kinetics or kinematics of a circular motion. Now we are going to discuss about dynamics of a circular motion. Means when the body is said to be in circular motion, what are the forces acting, how they are acting, what is the resultant force, this all the things we'll discuss it now. Shall we start, everyone? All of you? Yes?
Yes, sir.
Yeah. So centripetal force. This is for very important actually. So all of you remember this is for NEET, JEE, and as well as board exam. Everything it is very important. Okay. So let us discuss now what is centripetal. Is what is to say dynamics of circular motion. So dynamics means regarding about the forces. So we all knows about the circular motion at every point. Class 9th, if you go to that, as again I'm saying, a boy is swirling a stone by like standing in the middle, so that a body is continuously said to be in what, guys? A body is continuously said to be in motion. Yes or no? So now if you notice it at every point, if you take, let me take any point, we all knows that centripetal acceleration is acting towards the what, guys? All of you.
Center.
Centripetal acceleration is acting towards the center, and we can see tangential acceleration always act how? Tangential acceleration will act
Perpendicular to.
perpendicularly. So let us take at this point the velocity of the body is v, and at this point velocity of the body is v, and let me take some random direction. At this point the velocity of the body is like this, then also something is acting here. What is acting? Centripetal acceleration. So if I observe very carefully at any point, if I take, okay, so velocity, that is what tangential acceleration and centripetal acceleration, what is the angle between them? Everybody, it will be 90 degrees perpendicular to each other. Now see here, it is not looks like perpendicular. Still, what is the angle between them? Everybody, yes,
90
please. 90 degrees. So here also what is the angle, everybody? Here also angle 90 degrees, and here also angle 90 degrees. Now here you observe very carefully. So why we will say this circular motion is accelerated motion? Something is changing. What is changing at every point? Everybody?
Velocities.
Velocity changes. So why velocity changing? Because of what is changing? Everyone?
Direction.
Magnitude is common. So what is changing? Everybody? Direction is changing. So if it is direction is changing, then we can say velocity changes. Then rate of change of velocity, what we used to call? All of you? Yes?
Acceleration.
Acceleration. That what acceleration it is? It is a circular motion. So always acting towards the center. What acceleration we used to call as? That acceleration is called as centripetal acceleration. Centripetal acceleration. As the centripetal acceleration always act towards the what, guys? Towards the, yes, center or along the radius. So centripetal acceleration I can represent with the AC or AR. Keep it in mind. So centripetal acceleration means what? AC or AR. So we all know the formula. What is centripetal acceleration? Can anybody tell me? Centripetal acceleration formula. V square by R, or we can say R omega square. Am I right, everybody? Yes. Please respond. R
Yes.
omega square. So now we all knows that now somebody is making the body exerting the force on it. That is what we used to say. The force exerting the making the body to revolve. So whenever the acceleration is there from the class 9, so the force exerting on here, what force we used to call it as? This is centripetal acceleration.
Centripetal
so what
force.
force will be present? Everybody? Centripetal force. Okay. So centripetal force is existed. That is what we used to say that FC. What is the centripetal acceleration? Everyone? FC. Understanding? So now if you notice it from the class 9th, what is the relationship between force and Newton's second law? Anybody can tell me? Force and acceleration. Force is equals to. Please respond, Ra. F is equals to what?
Mass into acceleration.
Mass into acceleration. எல்லாமே தெரியுமா இது Newton's second law? F is equals to ma. Yes,
Yes,
or
sir.
no? Yes. From
Yes,
that, I can say force is directly proportional to acceleration. Is it right, Pradosh? Clear? All of you? Now, so we all knows that acceleration is a vector quantity, and as well as force is also a what? Force is also used to called as vector or scalar. All of you? Vector quantity. I'll represent force F is equals to m into acceleration. So now, if you notice it, direction of acceleration, that acceleration only we used to say centripetal acceleration, and force is also exerting in the same direction. Suppose if the body is in circular motion, all of you observe very carefully, always the body wants to escape like this, but the body is pulling towards the what? The force is some force is acting towards the what, guys? Everybody, center. Understanding? That is why the body is revolving in a particular path. Am I right? Everybody, clear? Yes. That is what. So something is pulling towards the center. That is why the body is continuously making in a circular track. So that force, which is the resultant force, which is acting the body to move in a particular path, that force only what we used to call, everybody? Centripetal force. Okay. And we all know that centripetal acceleration is also acting towards the center. So from that I can say both A and F acting in the same direction or different direction? Everybody, they are acting in the
Same direction.
That is what you have to remember it. Clear, everybody? So centripetal acceleration and centripetal force both will act always towards the what, guys?
Center.
Always act towards the center. That is what you have to remember it. Clear? Now, so let us find the centripetal acceleration formula, centripetal force formula. So from the Newton's second law, what is F is equals to? Everyone respond. F is equals to what? All of you.
MA.
M into A. So we all know that acceleration means centripetal acceleration. So force FC, centripetal force is equals to M into, what do you mean by centripetal acceleration? Solunga, fastly.
Yes.
V square by R. So that is only the formula for centripetal acceleration, centripetal force. Centripetal force is equals to mv square divided by what? All of you?
R.
R. Clear? R. We all knows that another formula for centripetal acceleration. What is the formula? M into
M R omega square.
R omega square. This is the another formula for centripetal acceleration. Sorry, centripetal force. So please learn it. Relationship between centripetal acceleration and centripetal force. Make it quick till here. Anyone having any doubt, you can ask. Understand, everybody? So for circular motion, what is the formula for centripetal acceleration? Sorry, centripetal force. Everyone. Centripetal force formula is what, guys?
MV square by R.
MV square divided by R. R we can say, what is that?
M omega R.
M R omega square. So please
Omega
make M R omega square. Any doubt till here? Please let me know, guys. Yes. I want response. Clear, everybody?
Yes, sir.
No.
Yes.
Yeah, please make it. Now, if you observe very carefully, the force which is acting towards the center, what is that force we used to call as?
Centripetal force.
Now, if you take that, go to the class 9th and see that one boy is tying a stone to the rope and he is trying to make it continuously in a circular path. Am I right or wrong, everybody? Yes, please. He is trying to tie to a something string. That is what we used to call as. We should not say string. It is not a force. The force, something is always trying to act towards to the center. So which will make the body to continuously flow in a circular path. Okay. Now, the force which is acting towards to the center, that is what we used to say circular, what we used to call centripetal force, which is actually, it is not the centripetal force, which is actually the tension of a string. Understanding the wire or the thread, what he is tying, that is what we used to call as tension, tension T. The tension which is acting towards to the center, that is only we used to call as, what we used to call, guys? Centripetal. Yes, please. Centripetal force. Clear, everybody? So now if you observe very carefully, if I consider this is the circular path, let me imagine just all of you. So now the boy is standing here and making to rotate the body. Now if you notice it here, now something is trying to pull towards to it, towards to the center, so that the object is always keep on revolving. Am I right or wrong, everybody? Yes, please.
Yes, sir.
And at every point, suppose here I will release the body, then the body will goes in a what direction? Definitely at that point it will goes in a straight line. Am I right or wrong, everybody? Yes, please.
Yeah.
Yeah, that is what. So let me take now the force which is acting towards to the center is F2, and the force which is trying to go away, take the ball going away, is actually we used to take it as a F1. So what do you mean by centripetal force? All of you observe, the body is again trying to follow the path. Then the centripetal force means the net force which is acting towards the what, guys? Net force which is acting towards the what? All of you. Towards
Center.
the center. So it is not actually the force. What force it is? It is a net force. Some forces are trying to pull the body away from it, and some forces are trying to pull the body towards to the center. Then the force, the net force of that one is only called as what force we used to call? Tension of a string, or we used to call as what, guys?
Centripetal force.
Centripetal force.
Centripetal.
Okay. So now let us consider chemistry. We all knows that always electrons are revolving around the what? We all take positive charge in the center and electrons are in negative. So we 9th class chemistry you might be studied. Electrons will never radiate the energy. Continuously they will be in a same constant speed. So how it is happening? Some force is exerting towards to the what? Some force is resultant force is exerting towards to the what? We used to call. Yes, please. That force only we used to call as what force making the electrons to revolve? Everybody, we used to call as electrostatic force. That is what we used to say, electrostatic force of attraction. This electrostatic force of attraction only in physics, the resultant force which makes the electrons to flow in a particular orbit. That force only we used to call as what force we used to say? Everybody.
Centripetal force.
Centripetal force. Clear? Now same way, let us take. All of you observe, this is the orbit where the earth is revolving. Earth is revolving about the sun. So this is the sun. So we all knows that the earth is revolving around the sun because of some force. Some force is exerted by the sun. What is that force we used to call as? Which is towards to the center. We used to call something
Gravitational.
called as, everybody? Gravitational force. This gravitational force only, what force we used to call as? Everybody?
Centripetal force.
We used to call it as centripetal force. That is what you have to remember it. Understand, Mr. Sai Gardik? Pradosh?
Yes, sir.
Yeah. So that is what you have to remember it. So whenever always keep in mind, FC is actually it's not existed, but total force acting towards the center only we used to call it as what? Actually, FC is not existed, centripetal force, but the finally sum of the total force which is acting towards to the body, towards to the center, which we used to call as what? We used to consider as, yes, please. We used to consider as a what? Centripetal force.
Centripetal force.
Okay. So FC, centripetal force is not existed really, but the total force which makes the body to revolve in a particular path, that is only we used to call as, we are considering